So here's a typical kind of problem that I'd expect a Calc 1 student to be able to do. Your job here is to evaluate the limit. That is, figure out what value this expression, the x squared plus x minus 12 all over x minus 3, figure out what value that expression gets close to when x gets close to 3. So as x approaches 3, let's see what happens here. When it comes to evaluating my limits, first step in my strategy is always see if all your limit laws work. If your limit laws work, remember this would allow you to take the limit of the numerator over the limit of the denominator, and then in your numerator you'd be able to take it a term at a time. In the grand scheme of things, if your limit laws work, this would allow you to just plug 3 in for your variable everywhere in your expression. So notice here, if I do that, my numerator is 3 squared plus 3 minus 12, that's 0. Okay. My denominator is also 0. So had my numerator and denominator gone to numbers like 1 and 5, my limit goes to 1/5. Had my numerator gone to 0 but my denominator went to -3, my limit goes to 0 over -3. Again, still 0. But because I see that my limit here has a numerator that goes to 0 and a denominator that goes to 0, that tells me two things. It tells me that I can't use my limit laws here. In order to be able to use my limit laws, I would need the denominator to not go to 0. That also tells me that anytime I see a limit in this form, it tells me I have more work to do. So here, in order to evaluate this limit, I'm going to have to do a little bit more work. Turns out, what I'm going to look for here is some way to rewrite this expression so that I don't have a denominator that's going to 0. So what we're oftentimes going to look for is we're going to look for something to cancel. If you're going to cancel anything in a rational like this, you're going to look to factor. So here's our strategy on this one. Let's factor both numerator and denominator. Notice my denominator already factored. My numerator, x squared plus x minus 12, I have to think about factoring that. So I'm thinking, there's my x squared. The only way I can get a -12 is if those signs are different. And I think that my numerator factors like that. Make sure you double check it. It works. And now, key thing that happens for us here, as x approaches 3, my original expression is equal to the expression that I'm working with now. And for the x values that I'm interested in, because I see that I can cancel things here, for the x values that I'm interested in, my original expression is equal to x plus 4. Now remember, our original expression here and our x plus 4 here, they're not always equal. They're equal everywhere except for when x is equal to 3. Now remember, a key idea with your limit here is that you're talking about values of x as they approach 3, but we're actually not interested in what happens when x is equal to 3. So everywhere where x is not equal to 3, our original expression is equal to x plus 4. And now, hopefully, now that I simplified my expression a little bit there, hopefully I can use my limit laws and evaluate this thing. Notice my limit laws would allow me to look at this thing as the limit as x approaches 3 of x, and the limit as x approaches 3 of 4. And those are two limits that I know. So I can see that my limit here is actually 7. If I were to look for what sort of info I would see on a test, once you guys get to here, I'm fine if you realize, hey, I can just plug in and go right to here, unless I happen to give you a problem that asks you for the steps along the way. So the limit as x approaches 3 of x squared plus x minus 12 all over x minus 3 is equal to 7. Notice we could check this by taking some values of x close to 3, plugging them in to our expression. We should get things close to 7. We could also graph this thing. And you could see that when you graph this thing, the points on our graph that have x values close to 3 should have y values close to 7. Graphically and numerically like that are great ways to get an idea of what a limit looks like, but make sure when we work with limits, make sure you can always solve them algebraically or evaluate them algebraically. That is, you should be able to show work that looks something like this.